Example 6, dividing complex numbers. To be able to divide complex numbers, you need to be able to multiply, by the conjugate. And you have to remember that the conjugate is the opposite of the one with the I. So on this one, we have to multiply both top and bottom. If it's positive 8i, we need to do negative 8i. We're going to multiply this. Okay? So that negative 8i goes into both of these here. Negative 8 times 3 is a negative 24i. 7 times negative 8 is negative 56. And that's 2i, so I squared. Remember, I squared is just negative 1. And then we have 8 times negative 8 makes negative 64. I squared. And I squared, remember, it's just negative 1. So we need to simplify this here. We need to put the real part first. Okay, so negative 56 times a negative 1. All of this equals a positive 56. All of this equals a positive 64. So 56 on top minus that 24i over 64. If possible, we do need to reduce. So what number goes into all three is 8. So if I take each one of these and divide it by 8, 56 divided by 8 is going to give me 7. 24 divided by 8 is 3. Got to keep that I. 64 divided by 8 is 8. Same thing with B. Multiply by the conjugate of the bottom. So the conjugate of the bottom, negative I, is now a positive I. So multiply top and bottom by I. So 3 times I is 3i. 8 times the 1 that's right there is 8. And there's 2i, so I squared. On the bottom, a negative and a positive make a negative. But there's 2i, so I squared. Okay, remember that we're going to rewrite this. And the I squared is negative 1. So negative 1. So we need, this is negative 8, right? So negative 8 is coming first because it is the real part. That's a positive 3i. Negative 1 makes a positive 1. So this final answer here is negative 8 plus 3i. Because we don't need that 1 on the bottom. Sometimes they're a little bit more complicated where it's got 2 numbers on the bottom instead of just 1. So your conjugate to this is 2 plus 4i. So the only difference here is that you're going to be foiling instead of just distributing. So 5 times 2 makes 10. 5 times 4 makes 20 with the I. I times 2 makes 2i. And I times 4 makes 4i squared. Now the bottom, 2 times 2 is 4. 2 times 4 is 8i. Negative 4 times 2 is negative 8i. And negative 4 times positive 4 is a negative 16i squared. Combine like terms, so the middle two for both. So I'm going to bring down my 10. 20 plus 2 is 22i. Remember that this I squared, it's a negative 1. So 4 times negative 1 is negative 4. Bring down our 4. The whole point of this is so that these should go away. So 8 minus 8, good, they go away. And that negative 16, that I squared is really a negative 1, right? So negative 16 times negative 1 makes positive 16. Simplify even more if possible, which there is. 10 minus 4 gives me 6 plus 22i. 4 plus 16 is 20. So if it's possible to have a number go into all three, we need to do it. So the number 2 goes into all three. So I'm going to take each one of these and divide it by 2. So 6 divided by 2 is 3. 22 divided by 2 is 11. 20 divided by 2 is 10. Same thing here. Multiply by the conjugate. The conjugate is, remember, opposite of the I. So 2 plus I. So 3 times 2 makes 6. 3 times I makes 3i. Negative I times 2 makes negative 2i. Negative I times 1 makes negative I squared. 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2i. Negative I times I is negative I squared. Remember that these I squareds are really negative 1s. So we have 6. Combined like terms, that's just plus 1i or plus I. Negative negative 1 makes a positive 1. 4. This should cancel, and they do. Good. Negative negative 1 makes a plus 1. So simplify this here. 6 plus 1 is 7. Plus 1i. 4 plus 1 is 5. No number goes into 7, 1, and 5, so this is our answer. Try these two on your own.